What is flow separation in F1 Aero design? Imagine driving a race car at top speed and suddenly feeling the grip vanish or the car slow down unexpectedly. That's often caused by a phenomenon called flow separation. In Formula One aerodynamics, flow separation happens when the airflow over a surface like a wing, floor, or bodywork stops sticking smoothly and starts to break away. This occurs when the boundary layer, which is the thin layer of air hugging the surface, can no longer follow the shape because of a pressure change. When the airflow detaches, it creates turbulence, swirling eddies and vortices that mess up the smooth flow. This turbulence increases drag, which is the air resistance that slows the car down, and reduces downforce, the force that pushes the car onto the track for better grip. Downforce is essential in F1 because it helps the car stay glued to the track during high-speed corners. When flow separates from the aero surfaces, the effective area producing downforce shrinks, causing a sudden loss of grip, often called a stall. At the same time, the turbulent wake behind the separation point boosts drag, making the car slower. To prevent this, engineers carefully shape the aero components to keep airflow attached for as long as possible. They use techniques like adding vortex generators or designing surfaces with specific curves and angles to energize the boundary layer. These small features help the airflow stay attached even when the pressure gradients are adverse. F1 wings are designed with precise angles and curvatures to avoid early separation while maximizing downforce. The floor and diffuser also relying on maintaining attached flow to generate ground effect, which is the low-pressure zone created by accelerating airflow underneath the car. If flow separates under the floor or diffuser, the ground effect is lost, reducing overall grip. That's why the 2022 regulations reintroduced Venturi tunnels under the side pods to accelerate airflow and boost ground effect, but only if the flow remains attached. Flow separation also occurs around the rotating front wheels, which create complex flow patterns. Components like flow deflectors are used to manage these separated flows, controlling the wake and minimizing drag or disturbance to other parts of the car. In essence, controlling flow separation is about keeping the airflow smooth and attached, which helps the car stay fast, stable, and agile through corners. It's a key part of F1 Aero design because when engineers succeed in delaying or controlling flow separation, they improve grip, reduce drag, and help the car perform at its best lap after lap.